All right, guys, we are beginning a new unit, and this really is going to flow smoothly from now until the end of the year. Integration, which is the verb of taking an integral, is the inverse of differentiation. Now, we already saw that the integral of a function from a to b is the area. Okay, we talked about this, but we're going to find out that there's a huge connection to differentiation, that they're inverse functions. And just like the actual definition of a derivative had to do with the slope, right? There was a rule for how to find the derivative anywhere. There's going to be a rule for how to find the integral anywhere without having to actually look at a graph. So that's going to make things a lot easier for us and give us a lot more power. So when we say we are differentiating, we say we are finding the derivative. When we say we are integrating, we say we're finding the integral or the antiderivative. Because the integral is the inverse of a derivative, sometimes we call an integral an antiderivative. And the symbol for integration is this integral symbol. Notice that it does not have numbers at the end. If you put numbers at the end, that will mean area, which we'll find they'll be incredibly connected to each other, but you can find the antiderivative without actually finding area. Okay, so as a quick warm-up, consider the power rule. Take the following derivatives. Go ahead and do these on your own. And hopefully we all know that to find the power rule, we take the derivative. We need to write y prime equals. We multiply by the power, so 3 times 2 is 6, and we lower the power by 1. X to the 1 power is just x. Here, we are going to multiply by the power and lower the power by 1. If it is written as a negative exponent, we can leave it as a negative exponent. If we wanted to, we could definitely rewrite this in the simplified form as negative 8 over x to the 5th. But again, if the original problem starts out not simplified, then it's kind of okay to leave it like this. This is also okay. Both of these are fine ways to write the answer if it starts with x to the negative 4th as in the form of the question. So this next one, the derivative is going to be, we multiply by the power, so 6 times 1 is 6, and we lower the power by 1. That's the power rule. When we take the derivative here, we multiply by the power, and we lower the power by 1. Remember, when you subtract a negative by 1, it will be negative, a lower negative. Some kids sometimes mess it up. And this is a fine way to leave it because of how it was written. But also, it would be fine to write positive 6 over x to the 4th. That's fine too. Finally, this last one, this is a power of 1. And so when we multiply by the power, 1 times 4 is still 4. And lowering the power, x to the 0 is just 1. So it becomes 4 times 1 is 4. Or you can just remember the derivative of x is 1. Okay, so here are our answers here. Okay, or here. These are also fine. Okay, so hopefully we're feeling good about the power rule, and we can write out in symbols what this means. How do you find which of these is the correct power rule? And hopefully we know that the derivative of x to the n power is you multiply by the power and you lower the power by 1. In words, we would say that you multiply by the exponent and lower the exponent by 1. Okay? Now, this is tricky, so think carefully about this. Remember that we said that the integral is the inverse of the derivative. And so to do the inverse of this rule, think back to your Algebra 2 days, or Algebra 1 days even, and when you're finding the inverse operations, there's something special you need to do when you're doing the inverse operations to get it right. So which of the following is how we would do the inverse of the power rule? And the tricky thing is that when you do the inverse, you do it in the reverse order. You undo the last thing first. So the very first thing we need to undo is whatever happened last. Since the last thing that happens when you're doing the derivative is you lower the exponent by 1, you need to raise the exponent by 1, and then you need to divide by the exponent. And the reason we need to do it in reverse order is because that's how we do any inverses. It's the same as if you're solving for like 2x plus 1 equals 7, and you're finding what x is. You're doing the inverse operations. This means that 2 times x plus 1 gives you 7. When you're undoing it, you don't divide by 2 first. You have to subtract the 1 first because that's the last thing that happened to x. And so similarly here, you need to undo lowering the exponent by 1 by raising it by 1, and then go back and divide by the exponent. So hopefully you feel good about that. Let's see how it works. Here, this is the derivative. It says it starts with y prime equals. This is actually a type of differential equation, which just means that it tells you what the derivative is equal to, and you need to find what the original function is. So find y. You need to find the original function. So if this is the derivative, then to undo it, to do the antiderivative, now it will be y equals, well, what's the power here? The power is 1. We're going to raise the power by 1, and then divide by the power, by the new power, right? So be careful, because we raised the exponent by 1, and then we divide by that new power. If you divided by 1, you would get an extra 2 here, and then when you try to do the derivative, you would get 4x, which would be wrong. So I guess up here we should say you divide by the new exponent, right? After you raise the exponent by 1. Let's be careful to make sure we said that. So we raise the exponent by 1 and divide by whatever that new exponent is after we raise it. Okay, why don't you try this next one? If y prime equals 3x squared, then y, the original function, must have equaled, well, we needed to raise the power by 1, so 2 plus 1 is 3, and then we divide by that new exponent. So it's just 1, so it's just y equals x cubed. We don't need to write the 1 here in either of these cases because 1 times anything is itself. Okay, how about y prime equals 4? What was the original function? Well, the original function was 4x. This has an exponent of 0, and when you raise it by 1, it'll have an exponent of 1, and dividing by 1 doesn't change anything. Or you can just remember that the derivative of an x is a constant. The derivative of x is 1, and so the integral of 1 is x. Okay. Y prime equals 3x to the negative 4th. Let's say you did. So y would equal, we raised the power by 1, so negative 4 plus 1 is negative 3. This will be x to the negative 3 power, and then we divide by negative 3. 3 divided by negative 3 is negative 1, and we just put a negative in front usually. Again, it's completely fine to put negative 1 over x cubed, but if it's written like this at the beginning, it's fine to leave your answer like this here. These are both correct. Okay, last one. This one's a little trickier. Y prime equals x to the 3/2 power. Well, we need to raise the power by 1, so 3/2 plus, how do we write 1 in halves? Well, 1 in halves is 2/2, that's 1. And so this will be x, so y equals x to the 5/2 power. And we need to divide by the power. So this is going to be dividing by 5/2. Dividing by 5/2 is the same as multiplying by the reciprocal. So dividing by a fraction is multiplying by the reciprocal of that fraction, so 2/5. So we can leave the answer like this because it was written like this at the beginning, but if you wanted to, you could rewrite it as the bottom is a square root of x to the 5th, and the 5th could either go on the inside or the outside. They're both fine. So hopefully we're feeling okay. Let's try a few more of these just to make sure we're feeling comfortable with how the anti-power rule works. I'll give you a few of these to try. Now let's go on to something else. You're going to find out that I've been kind of lying to you for the last like 3 minutes. Considering the following, okay? What are the derivatives of each of these? What is the derivative? So I'm going to just put them here. What's the derivative of y equals x squared plus 3? The derivative is 2x, and the derivative of a constant is 0. Okay, so y prime equals 2x. What about x squared plus 2? So y equals x squared plus 2. What's the derivative? The derivative is 2x. For y equals x squared minus 3, the derivative is, hopefully you got 2x. Again, the derivative of a constant is 0. How about y equals x squared? The derivative is 2x, and y equals x squared plus 12. The derivative is 2x. And what did we notice here? Hopefully we noticed a few things. Hopefully we noticed that all of the answers, all of the derivatives of these came out to be y prime equals 2x. And hopefully we also noticed the reason why that happened. The reason why all of these derivatives came out the same is because the derivative of a constant is always 0. And so if we have y is equal to x squared plus any constant, which we'll use c for the rest of this course to represent a constant, then if you do the derivative of a constant will be, well, the derivative of x squared will be 2x, and the derivative of the constant will be 0. And so it turns out, and by the way, when we say this constant, it could be positive or negative. So we only put plus c. We don't have to put plus or minus c because you could be adding like a -3, which would be subtracting 3 like in this one. That constant could be a negative, and so it's fine to just put plus the constant. Okay, so it turns out the derivative of x squared plus any constant or minus any constant would be 2x. And so earlier up here, when we said the derivative was 2x, and we said that the original function was x squared, well, this is one possible solution, is that it's y equals x squared. But couldn't the original function have been y equals x squared plus 7? That would have had a derivative of 2x. Or y equals x squared minus 5, that would have had a derivative of 2x. And so when we're doing the antiderivative, when we're undoing the derivative, it turns out that you can always add in a constant because the derivative of the x squared will go to 2x and the derivative of the constant will go to 0 when you take the derivative. And so whenever you do an antiderivative, there are actually an infinite number of solutions that all have that same derivative. Y equals x cubed has a derivative of y equals 3x squared, but so does y equals x cubed plus 101, because the derivative of y cubed equals 101 is 3x squared plus 0, which is also 3x squared. So we always put a plus c here, which means you can add in any constant you want. So this one should have been y equals 4x plus c, because the derivative of 4x would be 4, and the derivative of a constant would be 0. This one should have been this plus c, and this one should be this plus c. You have to add in a plus c every integral to show that there are an infinite number of antiderivatives, and this will come into play in just a few days. But for now, just every time you do the derivative or the antiderivative, you will always put a plus c because the derivative of a constant will be 0. So here is another one for you guys to try. What is the antiderivative of cosine of x? You can't use the power rule here, but I still think you can figure it out. What is the antiderivative of cosine of x? Another way to write this is the integral of cosine of x. Notice we didn't put numbers on the end. This says find the antiderivative of cosine of x. If you don't put numbers on the end, it just means find the antiderivative. And what is that antiderivative? What is the thing? When you're finding the antiderivative, you're finding the thing that when you take the derivative gives you that thing. So the antiderivative of cosine of x, hopefully you found, was sine of x. Because the derivative of sine of x gives you cosine of x. The derivative of sine of x is cosine of x, so the antiderivative is cosine of x. Okay. What about the antiderivative of sine of x? Be careful here. What is the antiderivative of sine of x? What thing do you need to take the derivative of to give you sine of x? And hopefully you did not just, oh wait, oh my God, hold on guys, stop, let's stop. We're gonna go back. This was wrong. What was wrong about what I put here? The antiderivative of cosine of x could be sine of x, but what's wrong here? This needs to be sine of x plus c, because the derivative of sine of x is cosine of x, and the derivative of any number is 0. And so it could be sine of x plus 7. The derivative of that will be cosine of x as well. So we always need that plus c. So with that in mind, what is the antiderivative of sine of x. The antiderivative of sine of x is not cosine of x. Be careful. The antiderivative of sine of x is close to cosine of x, but let's see, what would happen if we took the derivative of cosine? What is the derivative of cosine of x? Well, the derivative of cosine of x we know gives negative sine of x. So how do we actually get positive sine of x? Well, the antiderivative of sine of x needs to be negative cosine of x, so that when we do the derivative of cosine is negative sine, and so negative sine will give you sine. And what else do we need here? We need the plus c, because the derivative of a constant will always be 0. So what I don't want you to do is don't start memorizing a bunch of new rules. When you're doing antiderivatives, it really is more, instead of memorizing a new set of rules, just think about like, what is the thing you want to get the derivative of. So for instance, you don't want to memorize a new rule that says the integral of tangent of x times secant of x is secant of x. That's not a rule you want to memorize. Instead, you want to think, okay, what thing gives me a derivative that is tangent of x secant of x? And you should already know that the derivative of secant is tangent of x secant of x, or secant tangent, either way. So don't memorize new rules. Same with cosine, right? Like, don't memorize a new rule for the integral of cosine of x. Just think, what thing gives me a derivative that is cosine of x? This is the antiderivative. So you just need to think, what would give a derivative of cosine of x? And the answer is sine of x plus c, because the derivative of any constant is 0. This is something you super want to get used to never forgetting, okay? All right. So we'll try a couple of these other ones, see if you can see what they are. And let's define an antiderivative. A function, notice we use a big F here. This is often used for an antiderivative. You know how we use f of x for functions a lot, but it's always a lowercase f? We sometimes use a big F to mean the antiderivative. So a function is an antiderivative if the derivative of the big F is the little f, right? So this function is the antiderivative of this if you can take the derivative and get this. And notice that f of x will always be able to have a plus c because the derivative will always give you back the original function. Okay, so how do we solve a differential equation? This means, and we talked about it very briefly earlier, this means finding what y is equal to, what the original function was equal to. That's what we mean by solving it. And a differential equation contains y prime. It contains a derivative. There's actually, it'll be usually like the 3rd or 4th class of calculus. If you go on to be like an engineer or something, it's a whole course on solving differential equations. And, you know, I'm actually relearning differential equations right now. I've been doing that kind of in my spare time. And it can have like y primes in it. These can also be differential equations. Anything that has a derivative is a differential equation. And what you're doing is you're trying to find what the original function was that has those derivatives. Okay, so find the general solution. This means all possible solutions. And it's going to always involve a plus c. Find the general solution to y prime equals 2x. Well, the general solution is y equals what? Y equals the antiderivative of this. We raise the power by 1 and divide by the power. And so we get y equals x squared plus c. This is all the different original functions that when you take the derivative give you 2x. And they can have any constant. This includes x squared plus 7, x squared minus 1,003. Doesn't matter. All of these give you the derivative that is x, 2x. Okay? Let's look at a second. This is going to be a new thing, a new technique for how to find the antiderivative. So when doing integrals, there is no power rule. And there is no quotient rule. We learned when we were doing derivatives that if there were two things multiplying, I said power rule. Sorry, I'm sorry, product rule. There is no product rule. You can't take the integral of two things multiplying unless it's a constant, right? If it's a constant, we know that constant just stays alone. But if you have two functions multiplying by each other, you cannot do the integral of that. There is no product rule. And you will never learn one. And there is no quotient rule. If you have f over g, again, unless one is constant, if there's a constant, then it's cool because you could just rewrite it as multiplying by a constant. There is no quotient rule or product rule. And so it becomes really important in integrals to be able to rewrite as something we can do the integral of. So 1 over x cubed, this looks like a quotient, but we don't have a quotient rule. How do we need to rewrite this? Well, of course, we can rewrite it as a power rule. This is x to what power? This is x to the negative third power. And so now we can do the integral. Go ahead and do that integral. We raise the power by 1. So negative 3 plus 1 is negative 2. And we need to divide by that power. So this is 1 divided by negative 2. We never leave a negative in the denominator, so it's negative 1/2. So 1 divided by negative 2 is negative 1/2. And this is not done. We need a plus c as soon as we've done the integral. A nice trick is as soon as this integral symbol still needs to be here because we were just rewriting. We haven't actually done the antiderivative. This is not the antiderivative of this. These are actually the same thing. And so we still need that integral symbol. And as soon as the integral symbol goes away, the plus c will come. Okay, so that's a nice thing to make sure you're like writing things right along the way. I hope that wasn't off the screen there. I don't think it was, but I hope not. Okay, so because the original function was written this way, we should write this function simplified. This is negative 1 over 2x squared plus c. Okay, so hopefully you feel okay about that. How about this next one? You try this one on your own. How should we rewrite this? This is the integral of, this is a power. This is x to the 1/2 power. The root is what power it is, and it's to the 1 power. And so now we can do this. This is dx. So what is this integral? Well, we raise the power by 1. So 3/2. And divide by the new power. So dividing by 3/2 is the same as multiplying by the reciprocal. So 2/3. And as soon as the integral sign goes away, we need a plus c. Either you should have an integral or a plus c there. Here we still have the integral because we're just rewriting, and these are the same thing. We haven't done the integral. Here we have done the antiderivative, and so we need a plus c. And because the original one was written in the simplified form, I'm also going to write this. This does not go in the denominator because it is not a negative exponent. So this is just, the denominator is a square root, and it's x cubed. Okay, hopefully we feel okay about, oh, I lost my plus c. Okay, here's another one. We do not have a product rule. So figure out what you can do with this. How could we rewrite this in a way we could actually do it? Well, we can rewrite this as 3x squared plus 8x. We can just multiply this out. And this is cool because there is the sum or difference rule also applies to integrals. Remember when we were doing our integral properties, we said that the integral of a plus b, is the integral of a plus the integral of b. And so we can split this up. And that's because we can now see that the derivative rules will just be like, hey, find the antiderivative of this one, find the antiderivative of this one. Those will both give you the right derivatives. So what is the antiderivative of this? Well, we raise the power by 1, and we divide by the power. We raise the power by 1, and we divide by the power. So we divided by 3 here, that's why that's 1. Here we're dividing by 2, and this is 4. And, of course, what do we need at the end? Plus c. So x cubed plus 4x squared plus c. With that in mind, try to do this one all on your own. See what you can do. There is no quotient rule, but we can divide each of these by x. So x cubed divided by x is x squared. 5 divided by x cannot be simplified. It's 5 over x. This is, of course, 5x to the negative 1 power. And now I'm going to rewrite this, actually. X squared plus 5x to the negative 1 power. Now we can see it's all a bunch of power rule ones again, and we can do the integral. So we raise the power by 1, and we divide by the power. We raise the power by 1 and divide by the power, and ooh, we want to be careful here. When we raise the power by 1, we get 0, and 5 divided by 0 is undefined. This should set off alarm values. It's actually, yeah, so it's, this is undefined. This should set off alarm values. This is not power rule. This is not power rule. What is it? What is the antiderivative of 5 over x? It is 5 natural log of x. The derivative of the natural log is 1 over x. And so you have to be a little bit careful here because all power rule ones, so like x squared, x to the negative third, x to the negative fifth, all of these are power rule. Any power, 1/2 power, x to the negative 3/4 power, these are all power rule. But x to the negative 1 power is not power rule. First of all, you would be dividing by 0 if you tried to do the power rule, because you would be adding the exponent by 1 and dividing by 0, which is a problem. But also, 1 over x, the integral, is the natural log of x. Now, I'm not even going to start out by lying to you. When you do the antiderivative, you actually need it to be the absolute value of x. And it has to do with the fact that 1 over x has a domain of all real numbers. And to make the actual antiderivative work out on that domain, you have to be able to put in negative numbers for x. But you can't do log of a negative, like this is undefined. And so we make it the absolute value of x to actually make it extend over the entire domain. So whenever you do the integral of 1 over x, it's going to be natural log of absolute value of x, which is slightly different than when you're doing the derivative. But this is the answer. So plus c. Sorry, guys. This got a little messy. This was power rule. This one looked like power rule, but wasn't. Okay? Okay, guys. Let's see. Find the general solution to each integral. Use basic integration rules. So try this one on your own. Okay, hopefully you got that we need to raise the power by 1. These are adding and subtracting, so you can just do them all separately. So you raise the power by 1, divide by the power. 3/6 is 1/2. And so we want to simplify that. This is x to the 4th. We're going to divide by negative 1 by 4. So this is negative 1/4. This is going to be, we raise the power first, we divide by the power. And finally, this is a constant. And so the thing that gives you a constant is just an x. So it's just minus x. The derivative of x gives you a constant. If this had been like a 5, it would be 5x. So that's something worth remembering. It's slightly different. The integral of a constant is a constant times x. Just like the derivative of a constant times x is a constant. Okay, here is a tricky one. Let's see how you guys do on your own. How do you need to rewrite this? Well, you can't do a quotient rule. You can't do like the integral of the top over the integral of the bottom. All of that's terrible, but we can divide. This is x divided by square root of x plus 1 divided by square root of x. But we need to write this as powers. So this is x to the 1 divided by x to the 1/2. Here, this is just x to the negative 1/2. When you divide, you subtract the exponent. So 1 minus 1/2 is 1/2 power. So you subtract 1 minus, this is 1/2 power, and then this is x to the negative 1/2 power. And now you can do the power rule. We raise the power by 1, so add 2 halves, that's 3 halves, divide by the power. We raise the power by 1, so negative 1/2 plus 2 halves. Negative 1 plus 2 is positive 1/2. Negative 1 plus 2 is positive 1. So this will be x to the 1/2 power. And when we divide by 1/2, that's the same as multiplying by 2 over 1, which is multiplying by 2. So So this is just 2x to the 1/2. And guys, a nice check on yourself is when you do the, like you can just see, if you do the derivative, will this give you back what you just had? The derivative of x to the 3/2, you're going to lower the power by 1, and you will multiply by 3/2. 3/2 times 2/3 will all cancel out, right? 1/2 times 2 will give you the 1. And so it's a nice check to look back if you're not sure and see, hey, look back at this one. Was 6 times 1/2 3? Yes. Was 4 times -1/4 -1? Yes. Was 2 times 7/2 7? Yes. Is the derivative of -x -1? Yes. Oh my God, guys. I forgot to put the plus c here. That's so embarrassing. I'm telling you guys it's so important, and then I'm forgetting to do it. I apologize. Bad teacher. You guys are welcome to yell at me for that. This next one looks tricky, but I actually believe in your ability to figure out what you need to rewrite this as before doing the antiderivative. Which one of these forms is the right way to rewrite this? And hopefully you saw that we don't know how to do a quotient rule, and we can't make this into a power rule, so it has to be one of our trig ones. So I noticed there's a sine of x over cosine of x, and that's helpful because this is tangent of x, but there's an extra cosine of x here. So like, whenever I see sine over cosine, I'm like, maybe I could try writing that as a tangent. And 1 over cosine, that will multiply times this to make cosine squared. So 1 over cosine is secant. And so the integral of tangent of x times secant of x, this is one of our rules we should know, is secant of x. The derivative of secant of x is secant of x times tangent of x. And we need a plus c here because secant of x plus anything will give us this antiderivative, because the derivative of secant of x will give us this, and the derivative of a constant will be 0. All right, hopefully you're feeling more and more comfortable with this. How does this need to be rewritten? Hopefully you can just go ahead and get the right answer from here. I think you can do the whole thing. So we're going to rewrite this. By the way, when we're rewriting, it still needs to have this integral symbol because we haven't done the antiderivative. So this is going to be the integral of 4x squared minus x. Now we're going to distribute the -1 minus 4x plus 1. We could do the integral right here, but it's much easier to simplify first. It's always a good idea to simplify before doing the integral. This is minus 5x plus 1. And now we're ready to do the integral. This is 4/3 x cubed. So we raise the power by 1, divide by the power. Raise the power by 1, divide by the power. This will be x, and we need a plus c. So hopefully you feel okay about that. All right, how about this one? How do you need to rewrite it? Well, again, there's no product rule, so you can't do anything when they're multiplying. Let's change this to a power. This is y to the 1/2 power times y cubed. And you should know that when you multiply, you add the exponents. So how do we add 3 plus 1/2? Well, 3 in halves is 6 halves. 6 halves plus 1/2 is 7 halves. So we should know this is the integral of y to the 7 halves power dy. Notice that it has the dy here. It goes with the variable. And so the integral is going to be, we raise the power by 1. So 7 halves plus 1, that's going to be 2 halves. That's our form of 1 that we'll actually be able to add with 7 halves. So 7 halves plus 1 is 9 halves. And we need to divide by the power. That's 2/9 plus c. The integral of 4, what will give you that derivative? Well, it's just 4x plus c. The derivative of 4x is 4. Okay. Now, I will say this, guys. This is something that, just like when you were first doing derivative rules, it went really slow. This is probably going pretty slow for you at first, and it's a little bit hard. You're going to come back to this in like a week, and if you were to redo this entire lesson, you'd be like, oh, this is so easy, and you would finish this whole lesson in, honestly, like under 5 minutes. Like, from start to finish, you could redo these notes in 5 minutes, like a week from now, or maybe a week and a half. I don't know, something like that. I also want to point out one quick difference. When there is just an integral symbol, we're not writing y equals, right? But when it's a differential equation where it starts with y prime equals, so if it starts with y prime equals, this is saying the derivative function, the function for the slopes, is equal to 2x. So the original function that has these slopes, we need to write y equals. But if it just says do the integral, there's no y equals with it. So you may have noticed that this one had y equals, but these ones don't. So if it starts out with a y prime or y prime prime equals, we need to have y equals in our answer, because that's what solving a differential equation means, finding the original function that has that derivative. But if there's just an integral symbol, or like here it just said, what is the antiderivative of cosine of x? There's no y equals, and so it's just sine of x plus c. Okay, last example of the day, guys. If f prime prime of x equals 6x plus 12x squared, determine f of x. Here it tells us the second derivative, and we need to find the original function. So how are we going to do that? Well, we're just going to do it one step at a time, guys. If this is the second derivative, we can find the original derivative. We can find the first derivative, which is the antiderivative. Like the derivative of the first derivative is the second derivative. So we can do the antiderivative of the first derivative, which is what? So f prime of x equals, we raise the power by 1, divide by the power. We raise the power by 1, divide by the power. And we need a plus c. Now, this is something that's going to be a little tricky. When we do the integral of this, to find the original function, remember, this is when we solve a differential equation, we want to find what the original function was equal to. So we're not just finding the derivative, we need to go all the way to the original function. That's what the goal is when we're solving a differential equation. We just do the antiderivative again, but there's going to be one tricky thing. Do this first part. So this is going to be x cubed plus, this is going to be x to the fourth. When we divide by 3, it's 1. When we divide by 4, it's 1. But this is a constant. And when you do the integral of a constant, it needs to be a constant times x. And we need another constant. But these are not the same. When you use the same, like x has to be this, like if x is 5, it's 5 here and here and here. Here, this would be saying that these constants are the same value, but they don't have to be the same value. There could be one value of a constant here and a different value here. And so we usually call this C1 and C2. This means like, hey, there could be like 5x plus 7. If you put cx plus c, then it would have to be like 5x plus 5. But there's no reason these have to be the same. You can have any constant here and any constant here, and they will both work to give you the second derivative. And the reason is because when you do the first derivative, this one will go away, and this one will become a constant. And then when you do the second derivative, this one will also go away. And so you'll end up, you can have any number times x and any number there. Hopefully you're feeling good about this, guys. You'll get some practice tonight, and I will tell you this is the kind of thing that will just go faster and faster and faster once you get some practice. I hope you have a great day. This is a really important skill, and we have a mastery quiz on basic integrals coming up quite soon. I believe next class, you're going to have a mastery quiz just on basic integrals. And I'll throw that up on Blend. I'll throw you a practice one so you can see kind of like what it looks like. All right, guys, have a good rest of your day.